1, 6, 3, 2, minus 4, 0. So for example, if maybe in a multiple choice, they said find the determinant using cofactor expansion along the first row. They might say along the first row, along the first column, along the second column, along the third column, or they might say along the second row, along the third row. So what you need to do is determinant of A. For example, let's say they said along the first row. It's going to be 3. You multiply by the entry, and then you need to find the cofactor of entry. 3 is in position row 1, column 1. Then plus, you always putting plus. There's no negative. I'll show you another method where you can put a negative. It's almost similar. It's just a shortcut of using this cofactor expansion. 2 is in row 1, column 2. And then plus minus 1 cofactor, it's in row 1, column 3. It's always like this. That's your cofactor expansion. You're going to take the entries with their cofactors, and then you can find the cofactor of C11. Basically, that means you need to find the M11. So we can find M11. It's gonna be, if we delete this 1, then 1, we'll be left with what? We will be left with 6, 3, minus 4, 0. And then this will be 6 times 0. It's minus, right? 3 minus 4, which is 12, right? It's positive 12. Yeah, it is. And then now let's say because we need 3, right? We need 3. So now we need to find C12. Sorry. M12. We need to find M12. Then we need to find M13. So just change color here. Make it blue. 1, 2, that's row 1, column 2. And then we're left with 1, 3, 1, 0. And then determinant of a 2 by 2 is very easy. Just gonna multiply this 0 minus 3 by 1, which will be minus 3, right? And then now let's try 1, 3. 1, 3 will be 1, 3. We'll be left with 1, 6, 2, minus 4. This is equal to 1 times minus 4, minus 6 times 2, which is 12. This would be minus 4, minus 12, which is minus 16, right? And then from this we can find our our cofactors from our minus. In this case, we have 3, right? And then our cofactor here, it will be minus 1, right? And then 1 plus 1, just add these two numbers. It will be 2. Then we put the minor, which is 12. Then plus 2, negative 1. 1 plus 2 is 3. And then M12 is minus 3. Plus minus 1, which is this one. Maybe let me just say negative. Let me just say negative. Leave it. I'm just put negative. Minus plus plus and positive will be minus. Then the cofactor will be minus 1 plus 3 is 4. And then M13 is minus 16. And this should be 3 times 12, that is, let me just say 3 times 12. Then this would be minus because it's an odd number. It's gonna be minus, and then this minus will give a positive 2, 3, and then this will be positive. This will be positive, and then this minus will cancel this minus. That would be 1 times 16. And let me just check if, yeah, 16, that's 34, 36. Yeah, that's true. What is going on here? Sorry guys, I'm just checking something to make sure. C12. How do you get C12? Yeah, this is correct. 6 plus 16. Why did they get 12? In the book, they got 12 here. I don't understand how they got 12. C12. That's minus 6. Right? Oh, how did I get minus 3? C1 and then 2. Oh yeah, I messed up here. Should have put it in 2 here. This one. C12 said we cancel the 1 and then we cancel this one. So it's, yeah, I messed up here. I put a 1 instead of a 2 here. Because it's this one, then there's 3, there's 2, and then there's 0. So this will give minus 6 here instead of minus 3. See, you need to be careful in the exam because you might make mistakes, man. They do happen. Just gotta try and avoid them. So here it will be 6. And then here it will be 6. So here will be 12. Then the whole thing will be 64. This is called cofactor expansion. I'm showing you these because they might give you the cofactors, maybe in a multiple choice. So okay, here's a cofactor here. Find the determinant using these cofactors. You need to know what they're talking about. But if they say find the determinant using a cofactor and then they don't give you, if they don't give you the cofactors, but they do mention that using cofactors, there's a quite a similar way of doing this thing without having to write. Oh, you still have to do something like this, but not necessarily this formal way. This is like the formal way of doing it. But the other way, let me just do it quickly. It's just the same thing. Where's the matrix again? 3, 2, minus 1, 1, 6, 3, 2, minus 4, 0. Right, like this. It's still a cofactor expansion, but it's not as formal as that one. That one that I did, this one on the previous page, it's the correct way of doing it. This one, it's the correct way of doing it. But if they didn't mention cofactors like this in the book, you can just do it. It's still the same thing, but it's like this one. It's a it's a shortcut. So you're gonna make this thing positive, and then you're gonna make this thing negative, and then you're gonna make this thing positive. And then you just choose anyone that you choose any row or column that you're gonna use. You always have to choose a row or column when doing cofactor expansion. So in this case, we're just gonna use the same thing, the first row. So the first number is gonna be 3. And then we're gonna cancel this and this. So we'll be left with 6, 3 minus 4, 0. And then now we've got a negative here. Minus, then we put the entry here. 2, right? And then entry 2, that means we have to cancel this, and then we cancel this. So now we'll be left with 1, 3, 2, 0. And we come to this one. It's gonna be plus minus 1. And then if you cancel this and you cancel this, we'll be left with 1, 6, 2 minus 4, which will be 3. This would be 0 times this and this, 0 minus this and this would be minus 12. Minus 2, open bracket, this times 0 is 0, minus this times this is 6. And then this, let's just put a minus here. Open bracket, 1 times minus 4 is minus 4, minus 2 times 12, 2 times 6 is 12. We should still get the same answer. So this will be 3 times 12 minus, it will be plus, right? It will be plus 2, 6, because it will be like negative 2 times 6 times negative 6, which will be positive. And then this side is going to be negative. And then let's just put this together, minus 16. Then that's 36 plus 12 plus 16. So which is the same, 64. So this is how you would do it using cofactor expansion, the short way of doing it. But the correct way of doing it is this one. Let me know if it's the correct one, but the formal way of doing it, it's like this. So, and that means we are done with cofactor expansion. We have to go to row reduction. Row reduction. Row reduction is basically, it's just a clever way. It's also another, you could call it a shortcut. Is it? Okay, before we do this row reduction, I just want to show you this determinant. I mean, it falls under this. You know, we have, let me write it like this. You know, we have 3 row reductions, right? We have the one where you multiply a row by a constant. Let's call it K. And then exchange rows. Then the last one, you adding 2 rows, basically 2 rows. I'm just making a shortcut. Normally you'd have to multiply one of the rows. Multiply one of the rows. First, and then you add them. So we have like 3. Né? There's the 2, this one, these are the only ones that affects the determinant. This they affect determinant. These 2. This one doesn't affect determinant. When you exchange rows, you just know the determinant will be affected. Let's say I have yeah, I'm gonna use an elementary matrix. Yeah, I'm gonna use the matrix I. Let's say A is equal to 1 0 0 0 1 0 0 0 1. Right. This is the matrix I. Right. You know that the determinant of these the determinant of I, which is equal to determinant of I, you know that this is 1, right? It is 1 because you should just know that it is 1. But if you want to verify, just know that this is a diagonal matrix. So, and remember, a diagonal matrix, you multiply the entries of the diagonal to get your determinant. Okay, now let's say I have another elementary matrix. I will show you after this what an elementary is. But just imagine I swap row 1 and row 1 and row 2, and I call this matrix B. Row 1 and row 2, that means it's going to be 1 0 1, and then 1 0 0 0 0. So basically I swapped row 1 and row 2. The effect that this is going to have on the determinant is just going to be, if another way of determinant of B will be negative, right? Negative the determinant of A, because B is from A. So, but we exchange 2 rows. That means this is going to be -1. And then if we multiply by K, for example, let's say we have matrix C here. From this, let's say we multiply this by 3. We did one row operation on this matrix. It's called an elementary matrix, but I'll just dive deep into what an elementary matrix is. So we did one row operation on both matrices. Here we just swapped, only did one. That's why it's called row elementary. We did it on this identity matrix. You just do one row operation. It's called elementary matrix. Even here, we just did one operation. We multiplied row 1 by 3. The determinant here will be the determinant of C will be 3 times the determinant of the original A. In this case, it will be 3. This one, for example, maybe let me just dive deep into elementary so that I can explain. But this one, whenever you add, like for example, if I were to add row 1 and row 2, let me just do it quickly here. Let's say D. Let's say I add just two matrix. Got 1, 0, 0. Row 1 and 2, this would be 1. This would be 1. This would be 0. This would be 0, 0, 1. Then the determinant of D will just be 1. This doesn't affect when you add. The only two that affect is when you swap rows or you multiply row by column. But let me just show you because it's something we never did. Let me just show you elementary matrices. Because when they ask you on these things that I just showed you, when they want to examine you on this, they will probably want you to solve this thing by inspection, like quickly solve it by not writing anything down. You should know that this is the answer. That's how they will ask you, but you need to know what an elementary matrix is. An elementary matrix, basically, let's say you have an identity matrix. You call it I. And this identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? That's your identity matrix, right? Let's say I multiply by 1 of this matrix. Say I multiply by 3 or 1, right? This will give me 3, 0, 0, 0, 1, 0, 0, 0, 1, right? Then we call this let me put it here. Call this matrix, we call it an elementary matrix. I'm just gonna put a letter E. I'm gonna call it elementary matrix 1, right? And let's say we take the same matrix, just right here, say 1. Say we have 2. We have I again, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now let's say we multiply let me just look here. Simpler one. Oh man, I don't know where they were found. But then let's say I multiply, think of a random, let's say 4 times R1, let's say R3 plus R1, giving me R1. What do we get? 4 times this, we will get 1, 0, 1, 0, 0, 0, 1. 0, 4 times, that's 4. That's 0, that's 4. Right. And then the third one, I will show you, let me just quickly do this one first. This is equal to 1, 0, 0, 0, 1. Let's say we exchange row 1 and row 3, for example. We write it. We say 1, 3. I think this is how we do it. Sure. But basically 0, 0, 1, 0, 1, 0, 0, 0, 1. Right. Just call this elementary 2, this one elementary 3. They are called elementary matrix because from the identity matrix you performed one row operation and you got this matrix. Then from here you also performed one. Even here you also performed one. A typical question on row operations, how would they ask it? I think they did ask it. Does anyone have a question on row operations in the exam? I just want you to, because it's not difficult. The only tricky one is this one. It's this one. The two, these ones are easier. It's very simple to spot. You can just say, oh, okay, what's the difference between this matrix and this matrix? Oh, what the hell is going on here? Or what's the difference between this matrix and this matrix? And then you can spot, oh, okay, oh, these two rows are the same. Oh, there's a little bit of a difference here. Seems like they multiplied by 3. It's easy to spot. And then even these ones, you can see it's okay. These ones, they look the same, but it seems like they've swapped rows. But this one, it might be tricky. But in order for you, let's say, let me just erase this. Okay, let me do this. Let's choose a different one. Let's say I have let's say I have I'm gonna use I 0 0 0 0, and then maybe we have 1 0 3 0 1 0 0 1. So this one, what sort of row operation do they do here? How can you tell? Well, first of all, you need to know that, okay, I can see, right? This is definitely not multiplication, because the multiplication, one of the ones, they need to be increased, multiplied. Definitely not the first one. And it's definitely not exchanging of rows, because there's a number 3, right? If there's a number besides 1 and it's not multiplication, just like in this case, that means they added. And then now to find the correct addition, you look at your number 3, you mark it, right? Where does it lie? It lies in row 3, right? You're gonna take row 3 and say R3. The row it lies in, it's row 3. And then 10 minutes left. And then you're gonna say plus, right? 3 times the row it lies below or above. Like this. In this case, let's do another quick example. Say, I'm gonna make it a little bit different now. Okay, maybe let me just continue this. I will do a different one when we're doing exam past papers, because we need to finish this lesson so that next time we do something else. Say we have 1 0 7 0 1 0, 0, 0, 1, right? You can definitely tell, okay, this one is definitely not multiplication because they didn't multiply one of these ones. It's definitely not exchanging of rows because there's a number. Exchanging of rows, it's only once. You only need to see once. See, you only need to see once. And then multiplication, they only multiply one of the ones here. Everything remains the same. Here there's a 7 somewhere, which is replacing a 0. So that means they added 2 rows. What they do? Do the same thing. You highlight your 7. Where does 7 lie? In which row? It lies in row 1. You write it down. And then 7, it lies above row what? Row 3. So those were your elementary matrix. I wish I could just get one question on elementary matrix, but maybe we should continue. We should just continue with the determinants. If you can spot this, then you will know. I'm showing you this, I'm spending time so that you know, okay, if there's a 3 here and there's an elementary matrix, then the determinant is not going to change. That means I did something like this. And once I do something like this, the determinant doesn't change. It only changes once I do something like this. So in this case, determinant of E1 will be 3 times determinant of I. The determinant of I is 1, right? In this case, it's going to be E. Another way of writing determinant is just putting the E. It's going to be 1. It's going to be determinant of I, which is 1. In this case, determinant of E3 will be negative because we swapped rows. Determinant of I, which is equal to minus 1. So basically that's it. 6 minutes. Let me just quickly finish this thing of reduction. The determinants by reduction. Basically, you have. I'll just use an example to show this. You have. Let me use the same one. Oh dang. Let me just look for a simpler matrix. Can't find my pen. Oh, there it is. 3, 2, minus 1, 1, 6, 3, 2, minus 4, 0. What's going on? Okay. Let me mute him. So we have the same. We're left with 4 minutes. I think I'll finish it. 6, 3, 2, minus 4. Now let me do it like this. Let me do it like this. I don't want to confuse it with this other one. 1, 6, 3, 3, 2, minus 1, 2, minus 4. Just imagine this is a different matrix, and then you say find find they say find the determinant using row reduction. So basically, this is like a trick. It's like a trick. You just have to use row reduction and get zeros. You just need to get zeros by row reduction. For example, like we did in the first lesson, you highlight your first pivot point, right? And then you need to get a 0 here and a 0 here, right? So we do this by saying we need to add these two numbers to get a 0, but we can't just say 1 plus 3 because it's not going to give us 0. We can say minus 3 R1 plus what? R2 will give us R2. Then this side minus 2 R1 plus R3 will give us R3. And that matrix will be, what is this? That matrix would be, this one doesn't change because it contains the pivot point. Then this would be 0. Minus 3 times 6, it's minus 18 plus 2, that's minus what? Minus 16. Then minus 3 times 3, that's minus 9, plus minus 1, that's minus 10. Then minus 2 times 2 plus 2 is 0. Minus 2 times 6, that's minus 12. Minus 12 plus 16. Minus 12, yes. Minus 12 plus minus 4, it's minus 16. And then we have minus 2 times 3. Minus 2 times 3, that's minus 6 plus 0, yes, like this. So basically, we just need to get these zeros. And once you have these zeros, you can say, you can find the determinant of this matrix. 1, 6, 3, 0, minus 16, minus 10, 0, minus 16, minus 6, by saying it is equal to, you use this one, the one that has a lot of zeros, minus, then plus. So it's going to be 1, then you cancel this, minus 16, minus 10, minus 6, minus 6. And then these other ones would be zeros because of these zeros. So, and then you can just multiply these ones. Minus 16. It's gonna cut off now. Can we? We can do 30 minutes, right? Oh, because I just wanted to show you Kramer's rule and then we'll be done. Okay, I'm just gonna send you. I'm just gonna send a new link.